Arrays are objects that help us organize large amounts of information. This topic focuses on array declaration and use, balance checking and capacity, arrays that store object references, variable length parameter list, multi-dimensional arrays. Here are the topics. We're going into declaring and using arrays. The ArrayList class, introduced in Chapter 5, is used to organize a list of objects. It is a class in the Java API. An array is a programming language construct used to organize a list of objects. It has a special syntax to access elements. As its name implies, the ArrayList class uses an array internally to manage the list of objects. An array is an ordered list of values. The entire array has a single name. Each value has a numeric index. An array of size n is indexed from 0 to n-1. This array holds 10 values that are indexed from 0 to 9. A particular value in an array is referenced using the array name followed by the index in brackets. For example, the expression, and this is the name of the array, and to reference a value, they put the index in brackets. For example, the expression refers to the value 94, the third value in the array. Here's the array. 94 is at index 2. So to reference that value, they're going to use the name of the array and the index in brackets. That expression represents a place to store a single integer, and it can be used wherever an integer variable can be used. For example, an array element can be assigned a value, printed, or used in a calculation. So this first line, they're putting 89 at index 2. And this next line, they're assigning the value scores at index first plus 2. First is a variable. We don't know the value of that variable, but this is an integer. And this can be, say, 3. So whatever value is at 3, we're referencing it and adding 2 to it. Mean is equal to the score at index 0 plus the score at index 1 divided by 2. Then they're outputting the string top is equal to, and they print out the value at 5. And then they have a variable pick, and they assign it the value of scores at some random integer. And since they're passing in 11, this can be a random integer between 0 and 10, including 0, including 10. The values held in an array are called array elements. An array stores multiple values of the same type, the element type. The element type can be primitive data type or an object reference. Therefore, we can create an array of integers, an array of characters, an array of string objects, an array of coin objects, etc. In Java, the array itself is an object that must be instantiated. Another way to depict the scores array. The name of the array is an object reference variable. So an array is an object. So here's the object reference variable scores. It's pointing to a place in memory where the first value is 79, and then here are all the values in that array. Declaring arrays. The scores array can be declared as follows. So you have your data type, but you need the square brackets whenever you're declaring an array. Then they have the object reference variable scores. Then we use new. Once again, the data type. And then inside the square brackets, we put the size. So since they're putting in a 10, this can hold 10 values, 0 through 9. The type of the variable scores is int with the square brackets, an array of integers. Note that the array type does not specify its size, but each object of that type has a specific size. The reference variable scores is set to a new array object that can hold 10 integers. Some other examples of array declarations. So they have an int array, an array of doubles, an array of booleans. Here to declare the array first, and then they actually initialize it, an array of chars. The for each loop version of the for loop can be used when processing an array of elements. So here they're using the for each loop for scores, and they're printing out the values. This is only appropriate when processing all array elements starting at index 0. It can't be used to set the array values. See basic array. So what they're saying is we can use this for each loop to look at each element inside of this array, but we can't actually modify this array with this type of loop. We have to use the traditional loop if you want to modify values in this array. So here's a program that they have into the lecture. So they declare an array of integers and they pass in the limit. The limit is 15. That means we have possible values of 0 through 14. They use the traditional for loop and they iterate over that array and they assign values to the array using this loop. Then on this line, they change one of the values at index 5 to 999. And they use the for each loop to print out all the values. And here's the output. Here they're showing what happens in an array in the for loops. So the first thing that happens is after you declare an array, you have an array that could hold 15 items, 0 through 14. There's no data in any of these items. Then when they go into the first for loop, they add values. This is what the array looks like after it's been iterated 3 times. So they add values only to the first 3. This is what it looks like when it's complete. And somewhere in between here is where we assign the value 999 at index 5. And then this is them using the for each loop to print out each value in the array. Quick check. We'll write an array declaration to represent ages of 100 children. So we'll declare an array of the int data type of size 100. Write code that prints each value in an array of integers named values. So for the second one, we'll just use a for each loop. It's pretty simple. So here are the answers. So this is how we declare an array of ages for 100 children. We just specify the size And then if you want to iterate through values, we can just do something like this, the for each loop. Now remember, using this type of loop, we can't actually modify the values inside of this array. We're just getting the values. So this is only used when we want to view the values that are in this array. Bounds checking. Once an array is created, it has a fixed size. An index used in an array reference must specify a valid element. That is, an index value must be in the range of 0 through n-1. N is the size of the array. So if you declare an array that could hold 10 values, the highest value would be 9. So we just take the size -1, and that would be the highest index. The Java interpreter throws an array index out of bounds exception if an array index is out of bounds. This is called automatic bounds checking. For example, if an array codes can hold 100 values, it can be indexed from 0 through 99. If the value count is 100, then the following reference will cause an exception to be thrown. System.println codes count, so they're saying count is 100. So since the highest possible value is 99, once you get to 100, you have an array out of bounds exception. In chapter 11, we'll learn more about exceptions, but we're going to keep talking about exceptions as we get to chapter 11. It is common to introduce off by 1 errors when using arrays. So here's a for loop. They're saying for, they declare their integer, start off at 0 while index is less than or equal to 100. This is a problem because index will get to 100. So for every iteration, increment index by 1. So when we get to the last iteration of this loop, index will be 100 and we're going to have an array out of bounds exception. Each array object has a public constant called length that stores the size of the array. It is referenced using the array name. So here's the array. If you do dot and then length, you'll get the size of the array. Note that length holds a number of elements, not the largest index. See reverse order and letter count. So here's reverse order. So they declare an array of doubles and they're holding 10 elements. So they're going to have an index of 0 through 9. They print out the size of the array right here. So this is going to give us a 10. Then they go into a for loop. So they're going 0 through the length of the array, which is 10, but they're never actually getting to 10 because they're saying while index is less than 10. Increment index by 1. Then they're prompting the user to enter a number, but they're actually adding 1 to the index. So instead of saying 0, they're saying 1, right? So the first index is at 0. So if you add 1 to that, it'll be 1. So it's like a more natural for humans to start off at 1. So the first number they enter is actually going to go at index 0. They use the scanner to get the next double. They store all those values into the array numbers. Then they print out the numbers in reverse order, and then they go backwards. They're setting index equal to the length of the array minus 1. So they're setting index to 9. While index is less than or equal to 0, they subtract index. So you're actually getting the item at index 9 first, and then index 8, index 7, and you're just basically counting down. And here's what the output looks like. Here is the user entering in all the numbers, and they reverse the order of how we enter those numbers in. So they print out 99.18 first. Here's another example. So number of chars is 26. They create 2 arrays that hold integers. They say the size is 26, so that means you have an index of 0 through 25. They have char current. The comment says that this is the current character being processed. They have other is equal to 0. They counter for the non-alphabetics. So they prompt the user enter a sentence, and then they scan the line. So they're saying ch, which is an integer, is equal to 0, while ch is less than the number of characters in the line. Increment ch by 1. Then they grab the char at that index. So if you start off at index 0, this will be 0, then 1, then 2. So they're looking at every single character in the line entered by the user. They store that value into current, and they're checking to see if current is greater or equal to capital A and less than or equal to capital Z. If it is, then they're looking at their upper array and taking the current minus capital A and then doing plus plus. So A is a char, but when you use it as an integer, it's going to give you back the Unicode character number. If it's not equal to any of these, they do the same check, but for lowercase, and then they just increment other if it's not true for lowercase. Then they iterate over their array and they print out what values they have for the upper and lowercase letters. So this is what the output looks like. This is the sentence they entered. They processed that sentence and they took account of every character that they saw. Alternative array syntax. The brackets of the array type can be associated with the element type or the name of the array. Therefore, the following 2 declarations are equivalent. You have double with the array brackets right after double in the name of the array. Then you have double, the name of the array, followed by the square brackets. The first format is generally more readable and should be used. So the accepted practice is this first one. This other way is typically not used, but either way, it does the same thing. Initializer list. An initializer list can be used to instantiate and fill an array in one step. The values are delimited by braces and separated by commas. Examples. So they have an int array, they have their braces, here's the open, here's the close. Each value is an integer followed by a comma. For an array of chars, same thing, you have your braces, but the data type inside of the array are chars. Note that when an initializer list is used, the new operator is not used. No size value is specified. The size of the array is determined by the number of elements inside of the list. An initializer list can be used only in array declarations. So this means you can only use it when you declare your array, and you can't declare the array and then use it after your declaration. So here's an example where they declare their array using an initializer list and they just print out the values. Pretty simple example, and there's the output. Arrays as parameters. The entire array can be passed as a parameter to a method. Like any other object, the reference to the array is passed, making the formal and actual parameters aliases of each other. Therefore, changing an array element within the method changes the original. An individual element can be passed to a method as well, in which case the type of the formal parameter is the same as the element type. Alright, so I made this project called Arrays Demo 1. I just wanted to demonstrate some of the things we just talked about in the lecture. I know the first part of the Arrays lecture is actually kind of long, but I wanted to go over everything that the book talked about. So the first thing we're going to do is we're going to instantiate an array of a primitive data type. Now remember, arrays hold primitive data types, where array lists do not hold primitive data types. If you wanted to put primitive data into an array list, we have to use a wrapper class. So I'm going to go and demonstrate the array using primitive data type. So on line 3, I declared and instantiated an array object of 10 elements. This means my index is from 0 through 9. So now what I want to do is I want to print out what values are inside of this array. Now we haven't actually added any values to any of these elements, but I'm kind of curious to see what happens if we print those values out. So let's go ahead and do that. So I'm using Java's for each loop. I'm taking my collection of numbers and I'm saying for every iteration store it into the integer v, and then I'm printing out v. Let's go ahead and run this program. As you can see, what values are inside of this array are zeros. So since we didn't put any values, Java went ahead and used zeros as the values that we have in the array, even though we didn't specify 0. If you wanted to set a value at a specific index, you use the array and then the square brackets and specify the index. So here I'm setting the element at the 5th index, which is the 6th number, to the value 6. So now when I run this program, you can see that the 6th element is the value 6. So what's highlighted is an integer because that's the type of data it is. So you can actually use this in calculations. So here I'm using the value at index 5 and I'm multiplying it to 2. So 6 times 2 is going to give me 12. I'm storing that value in index number 6. Let's go ahead and run the program and see what it looks like. And there's my value. So if we happen to reference a value outside the index of the array, this is a runtime error. It's going to throw an exception, the array index out of bounds exception. So what I'm doing is not a syntax error, so I can run this program. But you can see IntelliJ is actually trying to alert me that the index is out of bounds. It knows from the 10 that I specified here that 19 is too big. But I'm going to go and run this program and let's see what happens. And here's the exception that was thrown, the array index out of bounds. So this happened because I went outside of the range of the array. So the highest value I can have is 9. If I go to a 10, I will get that exception, but 9 is my highest index because I specified I want 10 elements. So the first index starts at 0 and the last one is 9. So now when I run this program, everything is fine and you can see the last item is 19. So another thing to note is that this for each loop cannot change the values inside the array. So what I'm doing here is I'm saying that v is equal to 7. Now this is actually just changing the local variable to 7 and 7 will just be printed out here. Now if I run another for each loop like I did right here, it's going to print the values that I actually have in the array. So here's what happened. It's saying that everything's 7, right? But really it's because I just set the variable equal to 7. But if you actually look at the array, when you run it again, you can see that no values actually stuck with this 7. If I want to change the values of the array, then I have to use the traditional for loop. So I'm going to go ahead and set that up. Okay, so here's what I did. I went into my first for each loop and I commented out this line that was just making everything print 7, which was pretty useless. It wasn't actually changing anything in the array. So I'm using this for each loop to print the values. And then I'm coming in here, this traditional for each loop. So here what I'm doing is I'm started at index 0. Then I'm saying while I is less than the length of the array. So this is how we get the length of the array. We just do a dot length and then we increment I by 1. And I'm essentially just taking whatever values are already in the array and adding 1 to it. So I'm doing the plus equals. So everything that's 0 is going to go to 1. Is the 6, the 12, and the 19. Those are going to also increment by 1. But these zeros right here and right here are just going to be changed to the value 1. So let's go ahead and run this. So here's me printing out the values before I made my change. Then I used the traditional for each loop to add 1 to everything. And here's me adding 1 to everything. And you can see that whatever values I had up here essentially was just 1 more when I printed out the array the second time. So when I first instantiated my array, I just used this right here to instantiate my array, specifying the size and the data type. But you can also use an initializer list. So I'm going to go ahead and comment this out and I'm going to set up the same array, but I'm going to use the initializer list to set up the values. Alright, so here's me using the initializer list. So I went ahead and just set up 10 numbers. So I just use 1 through 10. Now IntelliJ is already telling me like the value at index 5 is already set to 6. And if you look at index 5, which is the 6th value, it's right there. So it's smart enough to know that these two are doing the exact same thing. So I'm just going to go ahead and comment that out. So the cool thing about the initializer list, it specifies the size and the values at the same time. So Java is going to use whatever numbers you passed in here as the size. So I passed in 10 values, so it's using the size of 10. So to prove this, I'm going to go ahead and do a system out print line and print out the length of the array. And this will give me the length of the array before any of this stuff begins. So I'm going to go ahead and run this. And you can see it behaves almost identical, except here are my values. I did modify some of them if you look at my code. And then I added 1 to everything. So I incremented everything by 1. So these are my new values. If I look at the length of the array, it's telling me the length is 10. Now if I wanted to increase the size of my array, I just add in new numbers. And I went ahead and added some new numbers. Let's go ahead and run this program. So now it's telling me the length of the array is 14, and I'm printing out all the values, and then I'm incrementing those values by 1.